All right, so the very last section that we're going to be doing utilizes tables of integrals. So when you go in the homework, you're going to see a blue link in each question that says use the table of integrals. And you might as well just download it and make a copy of it or print it out just so you've got it handy. It's 2 pages, okay? And all it is, remember that integration can be very, very intense. So people have sat down and figured out patterns to follow so that if you have an integrand that fits this scenario, you can just kind of sort of like plug and play, okay? So our mission in these 7 problems is going to be identifying which formula to use and then actually executing it. So we're going to have to find some A's, some B's, and some U's and DU's. And so remember that we are very interested in making sure that our DU's are balanced. Okay, so the first one that we have is going to be 10x over, and then 10 plus 11x dx. Now, I may or may not want to do this, but I'm noticing right off the bat that I've got a 10 times x. So this 10, I'm going to pull out front. So I actually have x over 10 plus 11x dx. So now I am going to start looking for that generic setup. Okay, so you can notice it's already organized for you. I've got forms involving a plus bu. Well, I don't have a square root, so I don't need this one. I don't have a square root. I still don't have a square root. Don't have a square root, and don't have e's or natural logs. Okay, so I know it's somewhere in here. I'm looking for, I know I've got a variable up top, and I know I've got a variable in the bottom. So it's kind of looking like I might have this format right here. So remember, your variables are going to take the forms of u's and du's, and your constants will be a's and b's. So what I want to do is make sure I've got all my bits and pieces. So I'm going to go ahead and assume that we are making this match formula number 1, which is of the form u du over a plus bu. Okay, and remember that du can either be on top or out to the side. So that dx could be up top or out to the side. So what is my a? Well, my a in this case is 10. Okay, what is my b? The b is the coefficient on x. So my b is 11. Well, what's my u? I've got a u here and I got a u here. I got an x here and an x here. So my u is x, and this is where you better pay attention. What's your du? Your du is 1 dx, which I have. Okay, that's why I pulled the 10 out front. So this 10 is going to come along for the ride in everything that I do. And when I look at this, I just have to fill in everything that I have for b's, a's, and u's. Okay, so I've got a 1 over b squared. Well, what is b squared? I have a 1 over 11 squared. So 1 over 121. Okay, times a plus bu. Okay, so all I'm doing is following this along. So a plus bu is going to be, a is 10, plus bu is 11x, okay, minus a, which is 10, times the natural log, I'm running out of room, of a plus bu, which is 10 plus 11x, and then plus capital C. Okay, so I could go ahead and just to simplify things, I could write the 10 on top there. Okay, so my answer for this one, just to be a little bit clearer because it's messy, is 10 over 121 times 10 plus 11x minus 10 times the natural log of 10 plus 11x plus capital C. So you're really just plugging and playing, okay? So number 2, I want to see how number 2 kind of fits in with this format. So we're looking at an x over something squared. Okay, so I'm looking for a u over a chunk squared. So I'm seeing that it pretty much matches up with number 3. Okay, so if what I have is the integral of x over 7 plus 8x squared dx, I want to know, I'm thinking this is number 3, Okay, so I want to know what is my A. So your A is just the constant that's being added. So it's a 7. What's your B? Your B is the coefficient on 8. And again, where am I getting this stuff from? I'm just following this pattern right here. So A is the constant, B is the coefficient. So B is going to be 8. And then what's my U? My U is going to be X. And there's my U over my U. Okay. And so I need an X, which means here's where you better watch out. Do you have your DU? Well, what's the derivative of X? It's 1. Okay, so I've got that. So it's 1 dx. So I've got everything I need. I don't need to balance anything. So when I fill this in, I get a 1 over b squared. So I get a 1 over 64 times, and then I have an a over a plus bu. So a over a plus bu, which is 8x, and then plus the natural log of a plus bu, which is 7 plus 8x, and then plus c. Okay, so that is your final answer. You're done. You're just making, the hardest part is going to be making sure that if you need to balance, you balance. Okay, so what is number 3? Number 3 is a 6x squared. So the integral of 6x squared, which again, I'm going to pull that 6 out front, 4 plus 5x dx. So this 6, I'm going to rewrite over here, and I'm just going to remember to put him everywhere I go. So I'm looking for an x squared over a addition problem. So here's a variable squared over an addition problem. So I'm betting it's that one. Okay. So I need to know what my a is. My a is 4. My b is 5. My u is x. Okay. And my du is 1 dx. So remember, it's giving you the x squared. So u squared is x squared. Okay, so I just need to fill this part in. So I've got a 1 over 2 b cubed. Remember, there's a 6 belonging to everything I do. So I have a 6 over 2b cubed. So 2 times 125 is going to be 250. Okay, so 6 over 250 times, and then we got a heifer of a thing. All right, so a plus bu squared is going to be 4 plus 5x squared. And then I have a minus 4a, so minus 4 times 4 is minus 16. A plus bu, so 4 plus 5x. And then plus 2a squared, so 2 times 16 is 32. Natural log of a plus bu, so 4 plus 5x. And then close those parentheses, plus capital C. Okay, and you're done. You can reduce that if you want to. But other than that, you're done. So let's look at number 4. So I got an x squared over 6 plus x. So x squared over 6 plus x dx. So again, I'm looking for something being squared over just the addition. So I'm looking through here, so it's going to be number 2 again. Okay, so what's my a? My a is 6. My b is 1. My u is x. My du is dx. So I don't need to balance anything. All I do is plop it on in there. So I didn't even have to pull anything out front this time. So I've got a 1 over 2 times b cubed. Well, b cubed is 1, so I have a 1 over 2. Okay. And then that is times a plus bu squared. So I have a plus bu squared. What is a? 6 plus x squared minus 4a minus 24. Okay. And then I have, hang on, plus 2a squared. So plus 2 times a squared will be 72 times the natural log of a plus bu plus c. Okay. So that is about all you get. And now we have, all right, so let's get into some scary stuff. All right, so for number 5, my setup is I've got an x squared times the square root of 36 plus 4x squared dx. So I'm looking for some square roots. And I'm looking for addition, and I need to start with a constant and then something squared. So I'm looking for just a plain old square root. Well, I've got an x squared. Okay. Well, I got a square root with addition. And then my u squared is also out front. So do I have a u squared out front? Well, I have a coefficient on mine. So let's see if there's one without a coefficient. There is not. Hang on, I'm looking. Okay, so we are now going to use part A. Okay, so we're going to use part A, but we're going to have to balance because my u squared doesn't match. So what do I have? My u squared says 4x squared. I'm missing my 4. So I immediately know I need a 4, which means I'm going to have to balance with a 1/4. Okay, so now what I have is my variable chunk squared. Okay, so I'm looking at this one. I've got my variable chunk squared times the square root of a constant squared plus the exact same thing squared du. So I just need to figure out what my u's and a's and b's are. So what is my a? Well, my a, this is supposed to be a squared. So if a squared is 36, what is a? A is 6. B. Do I have a b? Hang on, I'm looking. I do not have any b's. So what is my u squared? My u squared is 4x squared. Okay, so what is my u? My u is 2x. My du is 2 dx. So the question is, do I have the 2? So I need a 2 dx. This part is like a package deal. So I need a 2. So I need to balance with a 2, which means my lead coefficient is a 1/8. Okay, my lead coefficient is a 1/8. So what I have at this point is 1/8, and then just, good heavens, let me write it down here. Following this mess right here, I have a u over 8. Okay, so a u over 8 is going to be a 2x over 8 is x over 4. Okay, times a squared plus 2u squared. A squared is 36 plus 2 times u squared. So 2 times 4x squared is 8x squared. Okay, times the square root of a squared plus u squared. So a squared is 36 plus 4x squared. And then I have minus a to the 4th, which is going to be 36 times 36, which is a large number. Hang on. So 36 squared is 1296. So where did I go? I'm at 1296 over 8. And then times the natural log of u, which is 2x, plus the square root of 36 plus 4x squared. And then plus big C. So that closes, and then I have a plus big C. Okay? So that was number 5. All right, and I think I'm just going to let this video go long because we only have 2 more. Okay? So again, I need to find what my answer is. So for number 6, my setup is an x squared times the square root of 5 plus x squared dx. So I'm going to look for that format. I need a chunk squared followed by an a squared plus a u squared. So I got a chunk squared followed by an a squared plus a u squared. So it's formula number 8 again. So I need to find out what my a squared is. My a squared is 5, which means my a is the square root of 5. Okay? My u squared is x squared, which means my u is x and my du is dx. Okay, so I probably have more than what I need over here, but I'm just going to go ahead and flurf it on through. So I didn't need to balance anything because I've got my dx. You can't see. All right, so I'm going to start filling this in. I have a u over 8. So u over 8 is x over 8 times a squared plus 2u squared. A squared is 5. Yeah, let's make this a little bit bigger. There we go. A squared plus 2u squared, so 2x squared, times the square root of a squared plus u squared, so 5 plus x squared, minus a to the 4th. Okay, so that's 25 over 8 times the natural log. All right, so what did I just do? Square root of 5 times the square root of 5 times the square root of 5 times the square root of 5. Square root of 5 times the square root of 5 is 5. And then times the other set is 5, so I got 25 here. All right, times the natural log of u, which is x, plus the square root of 5 plus x squared. And then that is, okay, plus c. Watch your brackets, okay? Because now I've lost my paper. Where did I put my paper? All right, on this last one, that 1/8 belonged to everything. Yeah, we're good. Okay, so that x to the 4th only belong, or x over 4 only belonged to that first chunk. All right, people, the last problem of last problem of business calculus, and this video is running just a little bit long because I didn't want to make another one. All right, so I have the format of 1 over x times the square root of 1 plus 49x dx. Okay, so I'm looking for an x on the outside. I'm looking for an a and a b and an x and that kind of thing. All right, so when I'm seeing this is the forms involving a plus bu. I'm looking at 6 looks like a really good match. Okay, 6 looks like a beautiful match. I just got to make sure I've got my du. Okay, so what is my a? In this case, my a is 1. What's my b? My b is the coefficient on x under here, so my b is 49. Okay, what is my u? My u is x, which makes my du dx. So I don't have to balance, so I'm happy clam. Now I just got to fill everything in. Okay, and there's a qualifier that a has to be bigger than 0. In other words, no subtraction underneath here. Okay, so what I have is this. I've got 1 over the square root of a. So 1 over the square root of 1 is just 1, and that's irritating me, so I'm not going to write it. Then I have the natural log of absolute values, okay, plus c. So the first one, I've got the square root of a plus bu. So the square root of a plus bu, so 1 plus 49x. And then minus the square root of a. Well, what's the square root of 1? It's 1. Over the square root of a plus bu, 1 plus 49x, plus the square root of a, plus 1. And now we're done. That's it. Okay? So that is it for this. So now you are ready to go. And I will hopefully see you next semester.